Sri Gurubhyo Namaha. Welcome to our online teaching academy, Ekalaiva. Class 9, Subject Chemistry, Topic Atomic Structure, Part 2. In Part 1, we discussed about discovery of nucleus, Rutherford atomic model, and limitation of the Rutherford atomic model. And this class we are going to see about neutron, discovery of neutrons. In 1932, James Chadwick observed when beryllium was exposed to a alpha particles and it emits some rays. So beryllium plus alpha rays gives carbon and the one more particle that is known as neutron. Let me see about neutron. These emit particles carried no electrical charge and they are called neutrons. It is denoted by the symbol of N. It is denoted by the symbol of N. And this one is represent as mass and this 0 is electric charge. So there is no charge for the neutrons. Let me see about properties of neutron. These particles was not found to be defected by any magnetic or electrical field and proving it is the electrically neutral. It means there is no charge and its mass is 1.676 into 10 to the power of minus 24 gram. And in 1920, Rutherford predict the presence of another particle in the nucleus as neutron. And James Chadwick, inventor of the neutron, he was the student of Rutherford. Characteristics of fundamental particles. Let me see about atomic structure. What are the fundamental particles present in the atoms? The atom is built of the number of subatomic particles. There are three subatomic particles of the great importance in this. The structure of an atom are electron, proton and neutron. The properties of which are given in the table. Let me see about the symbol and the charge of the three subatomic particles. Electron. So it is represent as E and minus 1 is the electronic units and 1 by 1837 is the mass and the electron mass is 9.1 into 10 to the power of minus 28. Proton, it is represent as H, capital H, and one is the electronic units, the one is the mass, and 1.6 into 10 to the power of minus 24 is the mass gram, and neutron, N, mass 1 and 0 is the charge, electronic units, and the proton and neutron as the same mass. There are two structural parts of an atom, the nucleus and the empty space, and which the imaginary part is called orbit. The proton and neutron together to found a nucleus of an atom. So the addition of proton and neutron together is nucleus. Orbit. What is orbit? Orbit is defined as path by which the electron revolves around the nucleus. You can see here, and this is the proton and neutrons together nucleus, and this part is electrons, and here it is the proton Neutron. Orbits. Electron revolves in the orbit or shell. So this circular path is known as orbit. Let me see about atomic number and mass number. Only hydrogen atom have one proton in their nucleus. Only helium atom have two proton. Only gold atoms have 79 protons. This shows that the number of proton in the nucleus of an atom decide the which element. It is very important to important number is atomic number. The number is given. Atomic number is represent as Z, and the number of proton is equal to number of electron. So the atomic number is number of proton is equal to number of electron. Atomic number and mass number. Protons alone do not make all the mass of an atom. The neutrons in the nucleus also contribute to the total mass. The mass of electron can be small that it be ignored. As the proton and a neutron have the same mass, the mass of particular atom depends on the total number of proton and neutrons presence. This number is mass number. So total number of proton and neutron present is known as mass number or nucleon numbers, given as the symbol of A. So the mass number is equal to number of proton plus number of neutrons. So the mass number is equal to number of proton plus number of neutrons. Let me see how to represent the mass number, the atomic number. For any element, we have to represent as atomic number and mass number as the given below. So the A is the topmost letter. A is the mass number and Z is the atomic number. Number of protons in the nucleus, number of nucleons in the nucleus. And this X is the chemical symbol. So, for example, if I write carbon, C is the symbol and atomic number is 6 and mass number is 12. So this is the example. Carbon atomic number is Z, so 6 and mass number A is 12. Like that we have to write for the all elements. So for example, nitrogen as written as N 14.7. So the 14 is the mass number and 7 is the atomic number. Let me see about small activity. The following atom using atomic number and mass number. The first one is carbon. So carbon atomic number is 6 and mass number is 12. Oxygen atomic number is 8, mass number is 16. Silicon capital S and small I, symbol 14 is atomic number, 28 is the mass number. Beryllium beryllium 4 is the atomic number, 9 is the mass number. So we have to represent like that. The difference between mass number of an element and atomic number as given the number of neutron present in an atom of the element. So if you want to find out the neutrons mass number minus atomic number. So you can get a neutrons present in the atom element. Let me see a problem. Calculate the atomic number of an element whose mass is 39. Atomic number, mass number is 39 and the number of neutron is 20. Also find out the name of the element. So the mass number is equal to atomic number plus number of neutrons. Now we want only the atomic number. Then only we can find out the element. So atomic number is equal to mass number minus number of neutrons. So 39 minus 20. So if you subtract, you will be getting 19. So element having the atomic number 19 is potassium. So the element name is potassium. Electronic configuration of an atoms. You already know that the electrons occupy different energy cells. It is known as orbits or cells. The distribution of electrons in different cells are called electronic configuration. This distribution of electrons is certain rules. We have a certain rules to the distribution of the electrons in an orbit. The maximum, we have a rules for this. The maximum number of electrons that can be accumulated in the cells is equal to 2n square. So here the n is the number of cell from the nucleus. K, L, M, N. These are the 4 cells. So K is the first cell, L second cell, and M is the third cell, N is the fourth cell. So when you substitute this N1, you can get 2, 8, 18 and 32. So up to 32 electrons can be filled in the N cell. Rule 2. Shells are filled in a stepwise manner in the increasing order of energy. So 2, 8, 18 like that, increasing order of energy, the electrons can be filled. The outermost cell of an atom cannot have more than 8 electrons. Rule number 3. Even if it has occupied more electron, the outermost cell can occupy only 8 electrons. For example, the electronic configuration for in calcium 20. So Ca, calcium 20, K cell 2 electron, L 8 electron, M 8 electron, N 2 electron. So 20 can occupy like this. So we have to write the electronic configuration like this. What is the electronic configuration of aluminium? So atomic number aluminium is 13. Electronic configuration of aluminium atom. So we have to substitute the electrons K 2 and L cell 8 electrons and M 3 electrons. So the electronic configuration is 2, 8, 3. Thank you children. I hope you understand. Let me see next class.